You are welcome, students and viewers. In today's video, we are going to look at trigonometry and coordinate geometry. Coordinate geometry. Of course, in our last video, we have studied trigonometric functions. That is trigonometric identities, where we look at the Pythagorean identity and other identities derived from it. In today's video lecture, we are going to take some examples. So example, this is just the first example in this video and maybe the last example. So in this example, we are saying prove the following identities. Prove the following identities. So these are the following identities. A is saying sec theta over cot theta plus tan theta. This is equal to, so this is equal to sine theta. B, 1 over 1 plus cos theta plus 1 over 1 minus sine theta, 1 minus cos theta is equal to 2 cosec square theta. Also, C, we have tan theta minus cot phi sec theta all over, so here we have two angles, phi and theta, all over tan phi minus cosec theta. This should be equals to, if you prove it to be equal to tan theta cot phi, tan theta cot phi. D, we have sine square theta plus 2 cos square theta divided by sine theta cos theta to be equal to cosec theta sec theta and then plus cot theta. E part of the exercise. So the E part is saying cos power 4 theta minus sine raised power 4 theta plus 1. This is equal to 2 cos square theta. Now to begin, it's a solution and we start with A. So for the solution, we are starting with A, and what we are going to do is to take the left hand side and prove the right hand side. So we are starting from the left hand side, and the left hand side is saying sec theta over cot theta plus tan theta, so until we arrive at sine theta. But this is equal to sec theta is 1 over cos theta, so divided by, this is the division line, so I use this, So cot theta is the reciprocal of tan. So this is cos theta over sine theta. And then plus tan theta, this is sine theta over cos theta. So now what we are going to do is to solve this and then before the division. So I have 1 over cos theta divided by, so I take the LCM because to add two fractions you need to take the LCM and then simplify. So you see sine theta, cos theta, none is a factor of the other, and so their LCM is their product. So sine theta, cos theta is the LCM. So sine theta cos theta divided by sine theta, I have cos theta times cos theta. Therefore, here I have cos square theta. Sine theta cos theta divided by cos theta. The answer is sine theta. Sine theta times sine theta, so I have sine square theta. So with this, I have 1 over cos theta, because here is division, so I can take multiplication now to replace division, but to reciprocate, take the reciprocal of this fraction. So it is sine theta cos theta divided by cos square theta plus sine square theta. But you know cos square theta plus sine square theta, that is by Pythagorean identity, is equal to 1. So what I have here is, so I have 1 over cos theta times, here is 1. So I have sine theta cos theta divided by 1. So cos theta will cancel cos theta. All I have is sine theta. So this is equal to sine theta. And that is the proof. So we have arrived at the right hand side of identity number A. So now to solve B, let me clean here and then solve the question pertaining B. So for the B part, I have 1 over 1 plus cos theta plus 1 over 1 minus cos theta. So this is equal to, now to add, these are just fractions. Now to add, you need to take the LCM. You can see none is a factor of the other, and so therefore their product is their LCM. But so the LCM is 1 plus cos theta into 1 minus cos theta. That is the LCM. But if you multiply 1 times 1, you have 1. 1 times cos theta, you have minus cos theta. And then you have cos theta times 1, so you have plus cos theta. And then you have cos theta times cos theta, you have minus cos square theta. So minus cos theta plus cos theta will go. You have 1 minus cos square theta. So the LCM is 1 minus cos square theta. So now 1 plus cos theta, 1 minus cos theta divided by 1 plus cos theta. So you have 1 minus cos theta times 1. So I have 1 minus cos theta. I have 1 minus cos theta. So I have 1 plus cos theta, 1 minus cos theta divided by 1 minus cos theta. You have 1 plus cos theta and times 1. So you have plus 1 plus cos theta. And then you have minus cos theta plus cos theta. So you have, will go, all you have is 1 plus 1. The answer is 2 over 1 minus cos square theta. But 1 minus cos square theta by the Pythagorean identity, one of the identities we have proved in our last video, is sine square theta. So you have 2 over sine square theta. And 2 over sine square theta is equal to 2 times 1 over sine square theta. And that gives 2 cosec square theta. So we have arrived at the right hand side of the equation. All right. So now to solve equation problem number C, we need to write the left hand side and solve until we achieve the right hand side. Okay. So now to do that, we write tan theta minus cot phi. You know, theta and phi are two different angles, so be careful not to interchange or not to replace theta with phi or phi with theta. So I have this sec theta, so divided by, so you are dividing by tan phi minus cosec theta. So what is going to give you here sine theta over cos theta. Okay. Now minus cot phi, and cot phi is cos phi over sine phi, and sec theta is 1 over cos theta, so I write cos theta here. So this is it as the numerator, while for the denominator I have tan theta. So this is the division line I have replaced here. So tan phi is sine phi over cos phi minus cosec theta, which is just 1 over sine theta. So this is the denominator. While it is the denominator, I write this to be equal to, so you see here is a fraction, here is also a fraction. Now to resolve this fraction or to simplify this addition, so we take the LCM of this and also the LCM of this individually. So let's start with the numerator. So we are starting with this. So therefore the LCM here is going to be this, because 1 is a factor of the other. This is a factor of this, because sine phi cos theta contains cos theta as a factor, and so we'll take the LCM to be sine phi cos theta. Now sine phi cos theta divided by cos theta, that is sine phi times sine theta. So you have sine theta sine phi. Okay. All right. Now minus, this is the LCM. So minus, take this, divide by this. So it is itself, and therefore we just write minus cos phi. We are done with the numerator. Divide by, let's take the denominator here. So the denominator is here. So the LCM is sine theta cos phi. So the LCM is sine theta cos phi. The sine theta cos phi now divided by cos phi. You have sine sine theta sine phi. So you have sine theta sine phi for this. Take the LCM, which is sine theta cos phi. Divide by sine theta, you have cos phi times 1. So the answer is minus cos phi. So this as the denominator. So as the denominator, what we are going to do, so as the denominator, we simplify this, and it is sine theta, sine phi, sine theta, sine phi minus cos phi divided by, this is equal to, so divided by sine phi cos theta. So I have times, so to multiply, I say, okay, since this is this is division, and if I change it to multiplication, I have to take the reciprocal of this quantity, and the reciprocal is sine theta cos phi divided by sine theta. This one sine phi minus cos phi. So if you look at this, what we have here is sine theta sine phi minus cos phi. Sine theta sine phi minus cos phi. So this will go with this, cancel this, and what we have here is sine theta cos phi over sine, or we have cos theta sine phi. Remember, these are two different angles. So you write sine theta over cos theta times cos phi over sine phi. So this is equal to, for this now, for this you have tan theta, and for this you have cot phi. So this is cot phi. So the answer is sine theta cot phi as required. So that is the solution, just as it is in the right hand side. Okay. So now we clean the board and take example number D. For example D, okay, let me use this. What I have is sine square theta plus 2 cos square theta, sine square theta plus 2 cos square theta over sine theta cos theta, and that is equal to, so I can write this as sine square theta plus cos square theta plus cos square theta, because the meaning of 2 cos square theta here is cos square theta plus cos square theta. So divided by sine theta cos theta. But remember from the Pythagorean identity that sine square theta plus cos square theta is equal to 1. So I can take this now. So I have this is equal to 1 for this plus cos square theta. This is over sine theta cos theta, and that is equal to, so now common denominator, I can now split. So this is 1 over sine theta cos theta plus cos square theta over sine theta cos theta. And that is equal to, so 1 over sine theta is cosec theta. 1 over cos theta is sec theta. So I have sec theta plus cos square here, and I have cos. So this cos will cancel the square, and what I have is this becomes cos theta over sin theta, and that gives cot theta. And that is the right hand side we have achieved. So now the last, which is equation number E, or problem number E. To solve this problem number E, what we do is to say I have cos power 4 theta minus sin power 4 theta plus 1. So I am going to write the left hand side until I achieve the right hand side. And so this is equal to, so I can write cos power 4 theta as cos square theta all squared minus I write sin square theta all squared according to the law of indices. So I can write plus 1 here, but what we know is that difference of two squares. So this is cos square theta plus sin square theta into cos square theta minus sin square theta, and this one I put it plus 1. So this is equal to cos square theta plus sin square theta. The answer is 1 times cos square theta minus sin square theta, and then plus 1. So that gives cos square theta plus minus sin square theta plus 1. But remember, from the Pythagorean identity, we were able to achieve yet another interesting identity, which replaces sin square theta. So we write sin square theta is equal to 1 minus cos square theta, from one of the identities we have gotten in the previous lecture. So we replace sin square theta here with 1 minus cos square theta. So I have cos square theta minus into 1 minus cos square theta. So and this is plus 1. Okay, what we do is to rearrange now. I have cos square theta minus, so I have minus 1 minus minus, this is plus cos square theta, and then lastly plus 1. So what I have is cos square theta plus cos square theta. I have 2 cos square theta minus 1 plus 1, 0. And so the answer is 2 cos square theta as required. Thank you for watching our video. See you in the next video.